Can we start?
Is everyone
Rashford?
ready? Yes, yes, ma'am. Is everyone?
Yes,
Yeah,
yeah. Some they'll join by one. Still now it's 56%. We can start now.
sure, sure. Thank you.
Okay. Okay.
Yeah.
Yes.
Okay. So, good evening, everyone. Myself, Rajabharat Nagarajan, and
So sorry to interrupt you.
yes, please.
We'll just have a brief introduction about you. Then you can join.
Sure, sure. Yeah.
Yes.
Thank you. I would like to take this moment to introduce that
Yeah.
myself, Rajabharat
Yeah.
Nagarajan.
No, the staff will introduce you.
Okay,
Okay.
fine,
It's
fine. I
normal.
didn't hear that.
Okay. Okay.
Sure.
Okay. Okay. Sure. So, good evening, all. I welcome you all to the last session of this ATAL Online FDP and Smart Systems and Emerging Technologies in Industry 4.0. Today's session will be on digital twin technology in smart manufacturing and sustainable and green manufacturing technologies by Mr. N. Rajbharat, Project Manager, Saint Gobain India Private Limited, Chennai. Now I invite Mrs. G. Sheba, Assistant Professor of EC Department, to introduce about our speaker. Sheba, ma'am, please.
Ma'am,
Yes, ma'am. Yes, ma'am. You
ma'am, is it
can.
audible?
Yes, ma'am. It's audible.
Good evening, everyone. Mr. N. Rajabharat is a project manager at St. Gobain India Private Limited, Chennai, with extensive expertise in the domain of industrial automation and control systems engineering. With a solid professional background, he brings a wealth of hands-on experience in designing and implementing automation solutions across diverse industrial environments. He has strong technical proficiency in control systems design, PLC programming, HMI SCADA, and MES solutions with particular specialization in Ignition 8.1, Rockwell, and Mitsubishi PLCs, and platforms like Wonder Variant Touch, WinCC, and Factory Talk View ME and SC. Mr. Rajabharat has played a key role in delivering solutions for wastewater treatment plants, packaging applications, then servo drive integration, PAC-ML standard implementations, automation estimation, and costing. His expertise in PAC-ML and wastewater standards makes him a valuable contributor to automation-driven manufacturing and process industries. His practical knowledge in systems integration and project lifecycle management makes him a highly sought-after resource person for workshops, technical training programs, and industry academia collaborations in the automation sector. Welcome, Rajabharat.
Thank you, ma'am.
Thank you.
Yes, shall we?
Yes, yes.
Actually, I was a bit overwhelmed with the happiness that the one who taught me about engineering was like explaining my introduction. Thank you so much, ma'am. That is so nice to you. And before starting, I would like to thank our beloved HOD, ma'am, Ms. Durga Devi, for providing me this opportunity to share some insights on what I'm currently working on. So it will be useful for others, and also it will upgrade my skill set. So if something I can learn from you again. Thank you, ma'am. Let me share my screen.
Yes.
Hope my screen is visible to everyone.
Yes, yes, it's visible. Yes.
So today we are going to see about the topic digital twin technology in smart manufacturing. As the name itself would self-introducts, that digital twin means we are going to discuss something which we are going to have a twin. So either any physical thing that we are going to make it as a digitally twin in the digital world. So that's the latest technology which we are using in the industries to upgrade all the production, manufacturing efficiency and performance over the industries. Moving on to the agenda for today's session. First, we are going to check on the industry evolution. So before starting, what is the industry and what is the digital twin? We need to know like where we are and how the industry has been evolved from 80s, later 80s to current 2025. And we are going to have an introduction on digital twin, the basic understanding, I think many of the expertise here, and you would have already know about the digital twin, AI, ML, and all those stuffs. But the basic understanding will give you the connect, like what we currently work directly on the shop floor. I mean to say that in the industries where the digital twin has been utilized in the industries and the manufacturing, so that it can improvise the production, and the history of evolution, how it has been evolved from before today, and the core concepts, digital twin systems. And we have many types of digital twins, like we are going to see one by one in the upcoming slides, and its applications in over the industries, its benefits and challenges, and what are all the future trends we are going to have in a digital twin. And the final one, we will have a covering about the summary. On the first topic, that is industry evolution. As everyone would have already known, like we are like digitally evolved, like industrially evolved through digitization. So our first industry 1.2 was completely mechanization. So if any product has to be manufactured, it was like a purely into a manpower dependency through water and steam. So that is the first stage of industry. Now the second industrial era is like a mass production. The demand has been increased, so the production has to meet the demand, so it has to be produced mass. So to meet that, electricity has been used. So the industry 2.2 is being produced all the manufacturing through electricity. And the third one will be automation. Though there was some involvement in the physical manpower for the industrial to meet the production, and the third industrial era is like a it's the most upgraded one, where we have the automation solution, that each and every one of the systems has been automated from the human to the machines. So there we use the electronic digitals, PLCs, SCADAs, and all those industrial digitizations to upgrade the industry to a industry 3.0 standard. Now currently we are in the industry 4.2, where everyone would have known the common name like AI, ML, physical systems like cyber security and IIoT. And the future, what we are going to have is like a metaverse, human-centric sustainability, and it's a completely a collaboration with the AI, artificial intelligence. So why we are going to discuss on all these topics is like the digital twin is like majorly used in all of the industries to increase the efficiency and performance of the production. The production is the core heart, that is the core component of the any of the industries. If the industrialization has to be increased, the productivity has to be increased. So that is directly proportional. So in that case, to attain that, now we are in the fourth era. There we have AI. That is very powerful tool, and now everyone would have heard about that word. Wherever we go, we have the AI. So with the collaboration with AI and the industry, what we have, the digital twin comes under the industry 4.2 of AI. So it is like a one of the element in AIML. We are using it right now. And moving on to the next, industrialization, where the digital introduction of the digital twin. So for the digital twin, first we need to have a virtual representation of any physical object or a system. For example, if we are going to talk about twin, so obviously it can be like we are going to replicate something. So the source or the base, we have a physical system that virtually we are going to digitize in a digital world. The second one is real-time data integration. Third, simulation, monitoring, and prediction. And fourth is like bridge the gap between the physical and the digital world. Now everyone would have a doubt. Simulation and digital twin, both can be of same. Yes, actually, simulation is like for example, if we are riding a car and if we want to simulate that, we will make it as like a kind of a console video game. We can do all the things, whatever we are doing it in a real time, how we drive the car, same way we can replicate and simulate in the video games. But there is not any connection between the video game to the real car. So the digital twin is not like an exact simulation. It is like completely replicating the physical thing, make it work and alive, so that the data from the twin will be an input to the physical medium what we have it here. Yes. And the next one is like basic understanding. So I know many of the expertise here, but to my knowledge, like if we want to explain digital twin in a, like a very layman term, everyone would have used a smartphone and smart watches and any fitness trackers. So if we want to replicate any human with all these parameters, usually a fitness trackers, a watch or a smartwatch or a smartphone captures all these data through the physical sensors from your body, and it will gather all the data and it will process the data, and it will make a person, which is like it will create a twin in a cyber world, that is like a digital world. So obviously a physical person will be there. His parameters, like a health parameters, like a body temperature, step count, GPS, blood pressure, everything has been monitored. All these data has been transferred to a particular device, that is like a data collection, and the data has been analyzed and processed. And with this data, you can replicate a person in a cyber world. So it means, for an example, if any of the one parameter is like overshooting, or if any one parameter has any deviation, with that, the person in the physical world can adjust to it. So the performance of the physical person can be enhanced. So digital twin works on this core concept. So this is just a basic understanding how the system of the digital twin is being established in the industries with this basic understanding. History of evolution. Like whenever we are going to talk about any topic, we need to know the history, so we can understand that why this concept has arisen and what we are going to get out of it, and why this concept has been utilized over all the industries in this current era. So this is a small story. I would like to just give a gist of it. In 1960, NASA first used this simulations for Apollo mission. As everyone would have known, Apollo 13 launch, there was in 1916, and they had faced some oxygen tank explosion issues. So in order to avoid that, what they planned is they have digitally made the Apollo system, propulsion system in their in-house, and they got all the parameters from the real-time Apollo 13 propellant from here to the digital thing. And based on the data processing and the data analysis, they could able to analyze that by changing some of the parameters, the explosion can be prevented. So ideally, if any system has been is going to be introduced, the thing is like it needs to eliminate some of the risks, and it can be useful, and it has to increase the efficiency or performance in any of the way. So with this, they have introduced this digital twin technology, where they have started and implemented on their own Apollo 13, and it was successfully completed. So now they are integrated with IoT, AIML, and Industry 4.2 for the upcoming industrial eras. The core concepts of a digital twin. First will be the physical entity. As I already explained, if we are going to twin something, we need to have the physical entity. So we need to know what we are going to twin. That is the physical entity. And the next one is the digital representation. How we are going to grasp all the parameters digitally from the physical entity to our system. This is data connection. Once we get the data, and it has to be bidirectional. That means it has to be real time. It is not like we are getting the data, processing, and we are keeping the data. It is like real time. We need to pass in the information then and there. So any of the preventive measures or any failures can be easily predictive, and it can be sorted in the physical system from our digital system. And analytics and simulation. Yes. First, we need to have a physical entity. Then we need to have a digital representation on what we are going to we are going to twin, and how we are going to get the data. Like each and every parameters we need to receive from the physical entity to make it exactly same as a physical in the digital. And once we get all the data, and we are going to now do the data analytics. So here comes the major part. It is like a training an algorithm or a machine. So for example, if you put some 32 and 98, it will automatically tell that it is like a degree Celsius to Fahrenheit. So it means we need to train the data model that once you feed the data, it has to get the data understand, and it has to provide the output based on our understanding, like what the data model we have trained to it. So that is data analytics and simulation. And the final one will be the feedback loop. Why we require feedback loop is, without feedback loop, it will be considered like a, what I already told, just a simulation. You have a physical entity and the digital twin. And if the feedback loop is not closed, and if you don't have a feedback loop, then obviously these two exist separately. But in real time, we need to get the corrections and get and sort out all the failure and improve efficiency. We need to have the data loop flows from the both the end, like physical entity to the digital twin and digital twin to the feedback loop. So these are the core concepts of digital twin, what we currently practicing in our industrial standards. And characteristics of digital twin. First, connectivity, modularity, homogenization, reusability, and digital trace. Let me explain one by one. Connectivity. As I explained you in the
So sorry to interrupt. Your
is,
slides are not moving actually.
is that so?
It's
In which slide
displaying
I'm
the
writing?
first thing. It's just a minute, please. The first one, digital twin technology. Okay, that you can. I think you can choose your slideshow and then move it.
Shall I
Yeah.
reshare it again?
Yes. Yes. Yes.
Yeah, excuse me. Okay. Is it visible right now?
Yeah. 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 It's visible. It's visible. It's in core
Uh,
concept. Yes. Yes.
yeah, only this slide I have missed out, or shall I
Okay.
just come back from the
No
beginning?
issues. No issues. You can continue.
Yeah.
No issues.
So, okay, if anything, please interrupt me.
Sure. Sure.
Sure. Thank you. So these are the core concepts where we have, I'll just go quickly: physical entity, digital representation, data connection, analytics and simulation, and the feedback loop. So these are the 5 core concepts what we have it in a digital twin. Is it visible right now? I have moved to next slide. Am I visible?
Yes, it's visible. Yes, it's
Thank you.
visible.
So characteristics of digital twin, we have connectivity, modularity, homogenization, reusability, and digital trace. So if you take digital twin, like every system or every module, anything has its own characteristics. So it has to perform that way. So it can be easily utilized for other industries also. Maybe it's not for a particular way. So each one has its own characteristics. So the characteristics of digital twin are these 5 elements. And let me explain one by one. The connectivity. Connectivity is like linking the physical elements with digital counterparts. As I already told to you, like if we are having a smartwatch, we have all the sensor embedded in the smartwatch, and we are trying to, we have a tachometer, we have a temperature sensor, and we have a pulse oxy, everything in the digital watch itself. So it has to capture all the data and it has to send it to the digital technology. So we have a connectivity established in this digital twin. And next one is modularity. For example, modularity is like customizing the product on what we are going to do the digital twin, like modular based we are going to have. Why? Because in future, if we want to have any addition or if we want to extend anything, we need to have a flexibility that it has to be modular. So we are providing it is like a modular based. And the third one is homogenization. As we talk about digital twin, so we are collecting all the datas. The data can be, the datas are the heart of the industry. Like each and every one of the data is very very confidential. Maybe consider if we are working on any pharma industries, all the data what we capture, like a recipe for manufacturing any drug, if any 1 ml of any recipe has been altered, it will be a catastrophe. So the data has to be more secure. So the homogenization is like, though we require, though we take all the data from each and every segments, it has to be homogenized. That means it has to be separate from its physical form, and it has to be have it in a shell. So we call it like a data security. And next one is reusability. This digital twin has its own because the digital twins is like a part of AI using the sensors. So it has its own it supports automatic reprogramming. Like for example, if we are going to we are controlling any motor in an industry. If you take motors will be there, motors will be having a shaft and it will run the conveyor belts. So if we are trying to twin the motor, a part of the system, the component like the speed of the motor is altered in the physical form. We will have the same connectivity in the digital twin also. If we are trying to increase the speed in the digital and we are going to analyze what will happen, and once we get the feedback, like for example, the motor's maximum RPM is 1000 RPM, and if we are going to increase it to 1500, and we are going to check whether this supports this kind of a burst testing. So once we get the output like it supports, we pass on the data to the physical thing. So it gives you the flexibility and reusability of the whatever the physical component which we have already. If not, we need to purchase one separate motor with a higher rating. So we need to replace the existing one. But twinning the physical thing of a motor, you can easily able to get the understanding that, or you can able to have the proof that this device can supports maximum of these standards. The next one is digital trace. Digital twin technologies generate digital trace that help diagnose machine malfunctions. Okay, this is the major part where we are currently focusing on right now. So whenever we capture any data, it will be processed or analyzed. Though we are simulating it or not, we have the data and it will be analyzed. So from analyzing a data itself, you can able to predict that this device is going to have a failure at this time, because you have a standard. For example, we can consider a tire or a wheel in any of the bikes, and it has been manufactured, and it has been assured that it will be have a warranty of some 10,000 kilometers. And digitally, we are having the data for the manufacturing that particular tire in our digital system. Now we will try to analyze the data and check with this temperature. I mean to say Indian roads and Indian temperature, or particular specifically maybe or geographically specific with this within this region, it can be extended to some 2000 kilometers excess also. So it is not mandate that it can be 10,000, it can go up to 12,000 also. Because since we collect all the data during the production and post production, we have all the testing analysis. Now we could able to see the data and tell this device or this system or this module is going to get faulted within this time frame. So we can able to easily predict all the malfunctions. Next one is like a architecture of the digital twin. So if you consider a digital twin system, first we have a prioritization of data and data collection. So gathering relevant data for the digital twin. Next will be the data pipeline. As I already told, the data has to move from one flow to another, one medium to another medium. So it has to, for the processing and transferring data efficiently, we have to have a proper data connectivity and the data integrity. The data which we provide has to be more accurate data. For example, we faced this real-time incident in our one of the manufacturing plant where I have worked. I would like to share a small thing about it. For example, oven has to, everyone knows that oven, like what we have it in a home, it can be up to 180 degrees centigrade, but in the industrial, it will be like a larger scale. So it is like 1500 degrees centigrade. So there we have a products which kept inside to remove the moisture. And the problem is the connectivity between the data. We are real-time monitoring the oven in our digital system. We are trying to capture all the parameters, like all the thermocouples and the RTDs which is installed in the oven. We are getting the real-time temperature, what is inside each zone, what is the temperature of the oven, and the product also. The product worth will be around, it's like a larger number, like consider just approximately for 2 crores. So if any small malfunction happen, the complete batch will get failure. So we cannot do anything because it's an oven. That is the final stage also. So there is no chance you can retrieve some of the materials out of it. That the final stage, if the material is passed, it will be moved as a produced quantity. If not, it is a scrap. So why I am talking about the data integrity is the sensor which we had it in the oven was sending the data to our digital system with some 10 seconds of delay. Between that 10 seconds of delay, there was some overlap happened and the product got failure. So we always need to ensure that the data integrity, whatever we are providing, it has to be very accurate, and it has to be very prompt. Like, it has to capture that moment. We need to have a system to capture the real-time data, because if we miss any one of the data, and with that, if you are going to twin something or if you are going to analyze something, for sure it will go it in a different direction. And the data egress is the final stage, where we are managing the data output and sharing. Like, for example, once we collect the data, we have all the data for our reports, for our analysis and everything. So these are the basic architecture of the data part of a digital twin. Now coming to a digital twin system. Everyone would have known, this is the basic structure what we have for a digital twin system. So there, if you could see, you have a robotic arm. The robotic arm where we are collecting the data. So now we are trying to replicate or twin this robotic arm in our digital thing. So first we are going to collect the data, save the data, transmit. Once after transmit, it comes to a fourth stage, evaluate, and we have verifying. Then we simulate, evaluate simulation, we save the results. Then again, if you could see, we are transmitting the data parameter to the real product. And if we want to make any adjustments or settings, that we are doing it here, and you will get the final product. So it is like an infinite loop. You get the data, pass the data, collect the data, then you send it to the digital evaluation. There you have verify, analysis, simulate, evaluate, save with the results. Then you send this data as a parameter to your system to adjust automatically. So in future, if you are going to face anything, or if you are working in any deviation, it will get automatically adjusted. So these are the digital twin system, what we have it in the industries right now. So now you might have a question like digital twin, like how we are going to twin, on what we are going to twin. Yes. So twinning is like we can twin any of the like component. Like, for example, there is like a 4 basic categories of a digital twin. First one will be component or a part twin. So as I told you already, a specific in industry, if you take a specific sensor or a specific motor or a specific machine can be twin easily in our digital system. Next one will have a asset twin. So 2 or more components are a parts connected to a single element like assembly. We call it as an asset. That asset also can be twin. And the next one will be system, where we have a this multiple assets form a system. That system can also be twin. And the final one will be the process. If you take the process, the overall plant, we can able to twin. So these are the 4 basic digital twins, or the types of digital twins we have it right now. So component, asset, system, and process. Component can be of a single part. Like if you take any robotic arm, sensor, or a motor, or a valve, or a pressure sensor, anything it can be. Assets, like combination of components. If you have a particular conveyor belt system or a conveyor belt assembly, where you have a sensor, you have a conveyor belt, and you have a motor. So you have 2 or more components in an assembly, that call it as an asset. Or you can have a conveyor system and packaging system. So these two can be combined to like a 2 systems can be a twin. And also the process, overall the plant or the complete manufacturing unit itself can be digitally twin. So right now we have the one of the most successful story which we heard in our industrial evolution is like in Europe, France, one of the company has made the manufacturing plant from a brownfield to greenfield. That means they have a plant running in one location. They have digitally twinned that plant, and they could able to see all the parameter change for the new plant. And the new plant is right now implemented after implementing the digital twin. That means they have a running plant. They are going to copy this plant, and they are going to construct a new plant in some other location. So usually what we have, we will copy all the prototype structures and everything, and we will create the same plant to produce the same product. But what they did is like this running existing plant, they collected all the data, and where they are going to create the new plant, I mean to say manufacture the new plant itself, they have digitally twinned all this data and analyzed everything for 2.5 years. And with that, they have created a new plant, and the manufacturing output was from the day one with highest efficiency. Like for example, the existing plant has 75% efficiency. They could produce 90% efficiency with on the day one itself, because they had a data of 2 years of data for the existing plant to analyze and to correct all these things and to improve the efficiency of each and every whatever the problems they had it in the existing, that was completely sorted in the newer plant which they have created. So the digital twin helped in a vast way, so that the complete system, usually the traditional way is they will create a plant. So if you want to like manufacture any new manufacturing industries in any of the locations, first you need to see the geographic view, and you need to construct each and every one of, then you need to take the product trials, assembling of the machines, then you take the product trial. With the trial, it will come at like a final product. It will take around 3 to 4 months. Roughly, I'm talking from the finished of the construction part. But what they did is like cleverly, they have twinned all the manufacturing elements, assembling of the components, everything. So they have a complete data for 2 years, and they started the plant. And from the day one itself, they could produce the output with 90% of efficiency. So that way it has been like we are leveraging the digital twin in the manufacturing industries in the digital 4.0 era. Now, as on to the applications, first one, as I already mentioned, predictive maintenance. Like usually we have our washing machine in our household. So if we want to know like when this tub is uh, going to stop working, or it's going to expire its wear and tear, we need to get notified. So in prior itself we can have a maintenance. So that is like a predictive maintenance. So with this digital twin, you have the data which has been analyzed. So you could easily able to predict that this particular system needs to have a maintenance within this period. So it will not get completely gone after this many period. So you have a data to easily predict the maintenance part of it. And next comes process optimization. Yeah. Anyway, this maintenance is like a one of the benefits, you can say. And the process optimization is like a, that is like real need for the hour for each and every industry, because each and every process has to be optimized, because the company or the manufacturing industry would expect all the manufacturing products to be of 100% efficiency and 100% quality and 100% performance. So this we call it as an OEE, overall equipment efficiency. So everything should be 100% uh, in a literal way, but 100% is not achievable, but still they are trying to meet the standards. For achieving that, you need to understand the process. They have all the data now. They are trying to analyze the data. They can able to predict that this will come, this machine or this component may go faulty this time. So if they fix that in prior, they obviously the process has been optimized now, because it will not disturb the production in any of the way. Your production will go smooth because you have a data and you have a predictive maintenance. You are finding the errors in prior. You are optimizing the system because you have a continuous feedback system from the digital one. So you could able to tell that like, if I'm going to run in this standard, I will be getting this many output of the pieces. So if I want to increase something, and if I try to do that in a digital, if I could able to achieve that output, we will change the settings here. So obviously the process will be optimized. Next, the quality control. Quality control, this is also one of the major applications of digital twin, where each and every product has its own quality standards. For example, as I already told, if you take, we have a different types of industries what we have. So one of the basic thing is like if you take pharma or FMCG, like any food manufacturing divisions, we need to be very cautious on the quality data, quality parameters. So in future, if they require any audit, all these data has to be submitted. So the quality, like no company will compromise for this part, that I can tell sure about that. Because for example, if any food manufacturing company, they are producing or they are manufacturing any kind of eatables, it has to be of high quality. So this quality, the data will be fetched from the digital systems only. So for that, this digital twin is supporting us a lot, because even if in precise that this batch has this quality issues, we can able to trace it exactly to that particular. So like in late 90s and all, if you say you have the data but it not completely digitized, you could able to say that you have a batch where this manufactured batch has some defects. So you could not able to check part by part which part or which product we produced has an error. But right now we have a system which is very powerful, that it can able to tell us on this date, on this shift, this during this operator who has produced this batch, this is the batch number as a quality defect. Because we have a quality parameters which we are capturing it in a real time, and we have the standards. So if there is any deviation, it will be easily notify all the quality people to check on that and immediately respond to the quality metrics. Supply chain management. Yeah. So how supply chain management is like one of the applications of digital twin is like, right now, if you could see, like the same example I'm taking about any food manufacturing company, they are producing some biscuits. They don't know about the demand in the market, and they produce like based on their own, like earlier it was like based on the supply or based on the demand, the supply will happen, and based on that they will produce uh, all the manufacturing products. For that you need to have a raw material stock. So you need to keep your raw materials, that has to be enough to produce this many goods, that has to meet the demand of the consumers or the customers. So if there is any gap, then there will be like a problem for the industry. So this has to be balanced. Right now you have the data of how many products has been moved, how, like when, which season. Now you could able to easily predict that we have manufactured 1,000 biscuits, and in September month the sale was high, and we have produced it more. So up to that level they have all the details, because there might be some holiday or vacation time, anything. Just I'm randomly telling one scenario. So even to that level data, now we are capturing it from the system. So there will be always a proper supply chain management by leveraging this digital twin in the smart manufacturing. And the final, worker training and safety. How digital twin will provide the worker training safety is like, each and every operators or each and everyone who is been in the shop floor or in the manufacturing industry, their safety is high concern. So to that level, we are trying to capture the data. Even if any one person is not wearing the helmet in any of the shop floor, we have a camera, like we have image sensing, where it will immediately inform the operator, like this division, someone is violating the rules. So we have AI cameras where it will capture all the human activities. Also, we have the one who is driving the forklift. If they are going to have any heart attack, or if they are going to, if they are not in a physically good condition, that also the behavioral pattern of the operators also can be analyzed, because we have all the sensors installed in the forklift or inside the plant through cameras, machine vision cameras. Or if they have any biometric entries, you can able to provide the worker safety, like how many of the people has been logged in, how many of there in this division, how many of there in that division. So this is also one of the major applications in the digital industrial. Now coming to the benefits part. Yeah, again, this is like a loop. We are going to discuss the same thing, but the thing is like final. This should be the benefit. Like, we need to have a improved efficiency and the productivity. For that only, the industries are trying to uh, work on the technology, whichever is on leading technology. They are trying to leverage or adapt that to increase the efficiency of their manufacturing products. Now, reduce the downtime. Since we know this machine is going to get down, or this machine is not going to work on this point, we are in a position that to repair that or maintenance that before itself. So obviously the downtime will be reduced, and the cost savings, that is like one of the direct benefits. And enhanced decision making. For example, in like in a scenario like a COVID, if you want to produce mass, you can consider that usual production like was happening during the COVID. Our expectation, our demand was high. So in order to meet that, industry also has to be flexible to meet their demand. So they have to have an enhanced decision making, that when to keep the raw materials, how much they need to keep, and how much they need to produce, and how much uh, they need to check all the quality parameters also. So in order to have all this enhanced decision making, they need the data. So that data, we are always having it in our hand through this digital twin systems. Innovation in product development. Yeah. Since we have the data, now we have consider like in a small example, maybe it can be see, we have a biscuit, and if you want to innovate something over to that, and if you want to add a cream onto it, now we have the data, and we have our system, and we know the potential of our manufacturing unit. That means I have the company like a manufacturing industry. I know I'm producing this much. What innovation can be done to that through the digital twin? We can able to see that. Based on this, if we adjust some parameters within this, we can innovate some new products also. So there also we have a direct benefit out of it. Now coming to the challenges, any new technologies, though we have a lot of benefits, we have a challenges also equal to that, I would say. The first one is this digital twin system is like a high in cost. If you want to implement any digital systems in any of the manufacturing industry, first you need to have a data server. Then you need to, because we are going to collect all the data, then you need to install all the sensors to capture all the physical parameters from the plant or from the manufacturing things. You need to have sensors each and everywhere being installed to it. That is also will cost you a lot. And once you get the data, and it has to be analyzed in a data analyzer or a data simulator, the data analytic tool is very expensive. So if the industry will consider all these factors, once they are going to put this digital twin in their industry, they will just check, if I'm going to leverage the digital twin, how much output I'm going to get by investing this much capex to this particular system. So the high implementation cost we have. Data security and privacy, as I told, there is like each and every data in the industry is like a very it has to be very maintained very private. So for the data security and private, they need to have a separate data servers for it. So that is also one of the major challenges to it, because small industries cannot afford that much data security, though their data is not that much privacy. They need to have a data server to capture the data, then only it can be analyzed. And we have a complexity, because once we are getting the data, now consider I have an industry, I have installed all the sensors to get the data, I got the data. Now the thing is like, we need to know how to analyze the data. Keeping just the data, once it's been processed only, you will have some valuable information, otherwise it will be a raw data. So the complexity is like, we need to integrate and we need to analyze all these data, that we need to have a data analysis. And this digital twins needs for a skilled workforce, because a live example is been, I have been to France 3 months back, where I was working in a manufacturing unit. I just tried to install one new application in the manufacturing field itself, but everyone refused to use that. because the operators doesn't know about the computer knowledge itself. So in that case, like it needs to have a behavioral change also. So because everywhere you cannot implement a new technology and ask the people to use it, that will be really a tough task. So that also a greater challenge for this particular digital twin. And the scalability issues. Scalability in the sense, this digital twin system itself is like a tailor-made. For example, if I have an industry which produce food or any biscuit or something, for me, the separate digital twin has to be made like a module. And the same cannot be replicated to some other industry, because some other industry produces glass, means for that it has to be created separately. It is not like a plug and play, or it's not like modifying anything, or it's not like a generic applications like ERP, SAP and all. So wherever you put, it won't work. You need to understand the complexity of each and every process. You need to have the vision for it, like why we are going to digitally twin, and what we are going to twin, and what data we are going to get, which is the relevant data, and how we are going to analyze the data. That is more important. Then we need to have a final output. Okay, this is my issue. For that, I have taken this, processed this, and this is my output. Whether the output which I am predicted is matching or not. So the scalability issue will be there in the digital twin, because it's not like a ready-made plug and play system. For each and every industry, there need to be some audit, like we call it as a digital audit, or you can consider the evolution or we go to the plant, we assess each and every one of the elements in the plant. Roughly, if you take, you have a small manufacturing industries in Chennai that I have visited over there, and they produce some bikes, tanks, just a tank alone. So for them and all, offering this digital twin will be like a huge cost. But even they are going to leverage the digital twin. They are going to make some good profit, or they can increase the efficiency and the performance of the product. That is for sure. But they don't have that much physical uh, what to say, they don't have that much physical environment, like they don't have that much environment to grasp the data where they are in the industry 2.2 or 3.2 itself. First they need to upgrade it to 4.2. It has to connect it to IoT devices, like we have smart devices where we collect the data from each and every one of the product or the asset in the plant. With that, then only we can able to. So why I'm talking about this, like if you want to leverage or use of this digital twin in any of the industry, first the industry has to meet all these criterias. It has to be in digital 4.2, or you need to, if it is in 2.2 or 3.2, then you need to upgrade it to 4.2. Then you need to do all the architecture and all those things to acquire the data and do the output. And this is like a just a basic case study where I have been got this information from digital forum, where Siemens, they have made the manufacturing in the turbine manufacturing, they have used this digital twin. GE General Electricals, they have used it in jet engines and predictive maintenance. Yeah, that is one of the known thing for everyone. BMW, they have vehicle production lines, and other electronic smart factories, they have this digital twin. Future trends. Now we have covered up all the digital, what is digital twin, how we are going to get the data, and what is the relevant data, data security and all those things. In future, how it is going to get evolved. Now we have AI and machine learning integration. Everyone, like already all the expertise are here, they would have known about AI, so there is no specific thing where I can talk about AI. And also it is like a vast topic, it cannot be covered. AI has like a multiple sub elements out of it, like we have a machine learning, now we have a deep learning, we have AR, augmented reality, virtual reality, mixed reality. Now we are going to the concept of metaverse. So which is the most advanced one we are going to have it in the future. Why we have it, we are discussing that here is, the next stage would be integrating our machines with the AI and ML. So for now, we get the data, we have a physical, we get the data, we put the data, we analyze the data, and we are getting the output, and we are modifying it to increase our productivity. Now we have an AI system. We feed the data. This AI will tell you what to be adjusted, when to be adjusted. So with that, you can configure your settings to meet much more efficient way. So the future will be like augmenting with AI, 5G and real-time connectivity. Now many of the plans has been introduced in even in India. We have a 5G and real-time connectivity. Earlier it used to like a wired connectivity from each and everywhere. All the systems in the manufacturing plants, you will have all the wires laid, you and everything will be in a server station. There you get all the data. From there you connect it to your digital systems. Now we have 5G and real-time connectivity where the Wi-Fi routers has been installed in all of the plant. You will get the data wirelessly through wireless, like without any latency. You will get the real-time data. So whenever the product moves out from the conveyor, you will get a one count over the server room directly without any wired connections. Expansion into healthcare cities, constructions, etc. Yeah. For now, there is digital twin. Now we are using it in the manufacturing industries. Now it will in future, it will be replicated to healthcare and cities constructions and all those things. Like what I am already told is like constructing. Now you have a CAD diagram, right? So with the CAD diagram, with much more data, if you consider a CAD diagram is like a 3D representation of any structure or any building or anything. Now we have a data. With that data, you can tell if the rain is, just for an example, if it is raining for 3 days, will my basement withstand and the water is being logged with this much meters. We can simulate that scenario in our digital thing with the data, what we have it in a physical construction building. With that, we can able to analyze that, okay, my foundation has to be further increased in the strengthening part alone. If that case, even if it's raining for 5 days continuously with collecting of this much meters of water logging, it can able to withstand the condition. So it can be future enhanced or expanded to construction sites also. Human digital collaboration. Now we have already started like AI itself covers this. Already we have started collaborating with the digital twin systems. We have a voice commands, we have a gestures and all those things. And sustainability through digital twins. Sustainability is whatever we produce. Now we are going to talk about the reduction of carbon emission, because we whatever we perform, like even when we create an application or when we move any, like I recently read in an article that even when I make one click of a mouse, it emits one carbon to the atmosphere. So we need to be like very sensible to handle all these things when we are going to create any new technology or adapt any new technology. It has to be sustainable, and it should not disturb our ecosystem in any of the way. And the final summary part, digital twin bridges physical and digital worlds. So we have a physical entity and the digital entity. Now it's getting connected to both. Core to the industry 4.0 and smart factories. As I already told you, digital 4.0 itself, we call it as a smart factories because it's completely automated with IoT. You get all the data in real time. Earlier, you used to get the data through PLC SCADA, but it's not like a real time data. You have the data, it will be logged. It can be used up to some extent to the real time, not like exact way what we are using currently in the industries. Applications in predictive maintenance and optimization, that part we have covered up because the digital twins major concept is like a predictive maintenance. First of all, if the machine is not going to get down, you will have a production continuously, and you will know when it will go down. So you have all these things to predict and react according to the particular scenario. So optimization of the productivity also thereby directly proportional to the what we have it in here. And the final one is opportunities and challenges. Whatever we had, we have covered about the technology means we have an opportunity. We consider it as a benefits, and what are all the challenges we will be having it if we are trying to use the technology in anywhere. Yes, I think I'm at the end, and any questions, or if I want to reinstate any specific part, if I'm a bit speedy on that.
Participants, if you have any queries, Participants, if you have any queries, you can ask.
I know it's Saturday evening for everyone. I don't want to take much time of each and everyone's.
It's actually very good presentation. Um, like normally, this digital twin will be applicable for which sector the best? Like we have many sectors like industry, health sectors, and other things and all. Like this digital twin technology will be applicable to which sector? Like the effective way, in effective way.
Sector in the sense, can you bit elaborate on that part? Because we have a different manufacturing divisions or different manufacturings we have it in our everywhere. So if you want to make a sector in the sense like it's like a
Where
healthcare.
is yes, that's what I mean.
Yeah,
Like
right now we are having it much more in the production industries where we don't have this digital twinning process side. So even if you are making any application, or like I'm talking about the software part, not of the hardware production right now. So right now we have it in the all the production units, like whatever you manufacture, like even you have an automotive, and you have it in the glass, pharma, you have FMCG, you have. But the process side, if you take, you have a water treatment process. That is also a kind of industrial oriented approach. But still, the digital twin is not is being leveraged over there. So we have not yet touched upon those kind of industries, and we are trying to have it in a healthcare also on this. Right now, we don't have any case studies for that.
okay, thank you. Like what for student projects and all, like what tool they can use for implementing this digital twin model,
Okay.
or any project ideas can you give, like uh, for a btech level student?
Okay. The tool is like this has four components. Was what I previously explained. We have a separate concepts. So each and every core components has its own tool. That is why I couldn't able to give you the tool mapping, because for an example I'm talking about. First thing is like physical entity that you can consider any whichever you are going to twin. Like you can consider you are going to twin a motor. The tool is like for the data collection, you can get it through wireless, you can get it through IoT, you can get it through wired. So each and everywhere, what are all the like you cannot say it like a specific tools you have it where you can use it, because the data analysis part, if you take, you need to have a data analytics system. You have a lot many data analytics. Even whatever we have, the chat GPT or the deep seeks and all those things is like a basic data analytics tool. With the data what you are entering, it has been
నాకు
already
కొంచెం చూడు
trained
பண்ணி
to give
వచ్చాను
you the output.
తైరు నా కొడుకు
So there is no specific tool for each and every components or each and every concepts what we have it in a digital twin. Collectively, we call it as a digital twin technology, where each and every core has to be achieved through different tools only.
Thank you. And
Actually, we have a question on the chat box, which I hope the question is, can we model digital twin or can we simulate it for a particular application or a device?
Absolutely, we can. We can.
Okay. Any other questions from the participant side? Yes.
Also, we don't have any freeware to show the demo. Otherwise, I would have tried to show you some basic idea. Um, because each and every element, like for data collection, we need to go for some freeware. For data analysis, need to go for some freeware, and data simulation and data visualization. Like once we get the data, somewhere you can able to, you need to visualize the data like a dashboard or something. So each and every core, you can use multiple softwares or the tools to get those data.
Okay. One more question, Raj Vedit, we
Yes,
have.
ma'am.
Can you say any tools and technologies for digital twin?
Okay, we have an ignition that is like a more powerful tool. Like what I will try to say, ignition is like a tool where you can get the data, like data collection, data visualization we can make, and it has the data simulation and data. It has the basics of data simulation, but not to that extent. You can consider ignition as one of the tool through which we can try to uh, make the digital twin to up to some extent.
Okay. Any more questions?
Hello, I have one query.
Yeah.
Sir, like we are using IoT gateways. So let's say there is a gateway wherein I'm collecting the data from the sensors and I'm able to store the data in the cloud. Then, is there any way to, get that information from the cloud and showcase it into the digital twin?
Yes, we can. The main concept of the digital twin itself, you are collecting the data. You are either in a on-prem server or you have it in a cloud. The data has been stored somewhere. With that data, you need to have a data validation or data analytics. From the data analytics output, you can again feed it back to the machine itself. Possible?
Okay, thank you. Thank you, sir.
Yes.
Any more questions? Jasmine ma'am, so shall
Yes,
we
ma'am.
conclude ma'am?
Yes, ma'am. Yes, ma'am. Yes.
Okay. So I would like to express my heartfelt thanks to our resource person for his valuable contribution to this FDP program. We deeply appreciate his willingness to return as an alma mater uh, to his alma mater and contribute to the professional growth of our faculties. Your session on digital twin technology in industry with real practical examples was insightful, Raj Bharat. And also your presence added a special dimension to this program. Thank you for joining us, ma'am.
Ma'am. Thank you, Raj Bharat, for joining us. Uh, Really, the presentation was very useful, and we can see the efforts. The slides are also very clear, and it was very impressive. Really, thanks for accepting our invitation and for delivering a session. Thank you.
Thank you so much, ma'am. And I'm proud to say that I'm an alumni of the New Prince Bhavani. So, uh, if anything in future, I would ready to help you, like in any of the way where I can. So I can share the any of the contents or the tools. If you need anything, you can contact your ma'am Hema ma'am and Shiva ma'am HOD is there. So I can try to support you guys if I could in any of the things in future.
Sure.
Thank you
Thank
so
you.
much for the opportunity.
Okay,
Thank you
thank
so
you.
Thanks
much,
to
Raj.
Durga ma'am, Hema ma'am,
Really,
Shiva
we're
ma'am.
very proud to have your words here. Thank you.
Thank you so much, ma'am.
Yeah. I request all the participants to turn on your video for a photo.
Ma'am, I can't able to open my videos, ma'am.
Ma'am, you've given the yeah. Now you just try, ma'am.
Yeah, ma'am.
So participants, kindly switch on your video. Thank you. Thank you all.
Thank you and have a wonderful evening. Thank you.
Thank you, sir.
So the validatory function will start by 6:30.
See, please don't leave the meeting. You just take a short break and be present. Attendance for the validatory section is also taken into account. So kindly cooperate. As of now, we are seeing some 120 participants. The same we expect for that validatory session too. Then after that, you have to give the feedback and other things and all. So please join with 6:30. Don't leave the meeting. Just go take a small break and then come. Thank you.
Jasmine, ma'am,
Ma'am, yes, ma'am. Start, I think.
shall we start?
Yes, ma'am. Yes, ma'am.
Have you connected with our HOD, ma'am?
Yeah, yeah, you just start. Ma'am?
Yeah, I'm ready. We can
Yes,
start.
yes, yes, ma'am.
Yes, ma'am.
Thank you.
So, good evening, all. It gives me an immense pleasure to welcome you all to the validatory function of this 6-day ATAL FDP program on smart systems and emerging technologies in Industry 4.0, organized by Department of ECE, New Prince Shri Bhavani College of Engineering and Technology. I would like to express my a warm welcome to our principal, Dr. T. Saravanan, whose constant support and encouragement made this FDP possible. Next, I would like to welcome all the faculties of our college and a special welcome to all the participants from various institutions whose enthusiastic participation made this FDP a vibrant and a meaningful journey. Over the past 6 days, we all have been engaged in an enriching academic journey that brought together a wide spectrum of knowledge, ideas, and innovation in the field of Industry 4.0. The resource persons, with their expertise and experience, have enlightened us on the crucial aspects such as artificial intelligence, Internet of Things, machine learning, edge and fog computing, blockchain, which are reshaping the industries and society today. So, as we are moving forward to the concluding part of this program, to give away the formal validatory at the start of the function, I would like to invite our head of the department and Dean Academics, Dr. G. Durga Devi, a leader who have been instrumental in successful organizing of this FDP program to address the gathering. Ma'am? Ma'am?
Yes, I am not able to switch on my video.
It's okay, ma'am.
Yeah.
Yeah.
Um, you're able to hear me, right?
Ma'am,
Ma'am.
yes,
Yes,
you're
ma'am.
audible, ma'am. You're audible.
Yeah, okay. A very good evening to one and all present here. It gives me immense pleasure to address you all for this valedictory session of this enriching FDP on smart systems and emerging technologies in Industry 4.0. Over the past few days, we have all had the opportunity to delve deep into this technological revolution that is reshaping the very foundations of industry, education, and society as a whole. So Industry 4.0 is not a buzzword, right? It represents a shift powered by emerging technologies such as artificial intelligence, IoT, robotics, big data, blockchain, and so on. For us now in the academic world, especially those who are all engaged in higher education, it's an opportunity and a challenge for us to shift between these fields. As educators, our role is not only to adapt to this new industrial revolution, but also be equipped to, we have to equip our students to thrive within it. This demands a shift from traditional methods of teaching to more interdisciplinary, technology-based, integrated, and outcome-based approaches. And this, I think this FDP has served as a meaningful platform to explore these ideas, to learn from experts, learn from the experts, resource persons, and expertise who had a large amount of expertise in these fields. I hope you are able to share your ideas, explore your ideas with the resource person, and engage yourself in thoughtful discussions and reflect on how we can align our teaching with the demands of Industry 4.0. And let us not allow this program to be an end in itself. Rather, let it be a beginning, a catalyst for innovation in our pedagogy, curriculum design, and academic planning. Let us remain lifelong learners, just as we encourage our students to be. On behalf of our institution, New Prince Sri Bhavani College of Engineering and Technology, I would like to express heartfelt gratitude to all the resource persons, organizers, and above all the participants whose enthusiasm and engagement made this program a grand success. I wish each of you the very best in your academic and professional journey. May we continue to collaborate, evolve, and contribute meaningfully to shape the future of education in this era of transformation. Thank you once again. I wish to finally, I would like to thank the coordinators, Dr. V. Mangairkarsi, and co-coordinator, Dr. Jasmine, who did their part very well. Were able to join us, all the participants join to the FDP in a very, very good manner. Thank you all. Thank you all. And also, I'd like to thank the management for supporting us in this FDP. Thank you. And once again, I would like to thank the participants. Thank you.
Thank you, ma'am. Now, let us take a look back at the highlights and the learnings of this FDP. I request our program coordinator, Dr. M. Jasmine, Associate Professor of EC Department, to present the FDP report. Over to you, ma'am.
Yes, ma'am. Good evening, all. The faculty development program was conducted successfully with the objective of enriching the knowledge and skills of the participants in emerging areas of technology and research. Over the course of the sessions, distinguished research persons from academia and industry shared their expertise, covering both fundamental concepts and advanced applications. Day one, we started the first session, Edge AI and for Industrial IoT, VLSI Design Challenges and Opportunities by Mr. Prashant Nagarajan, Director, Epical Layouts Private Limited, Chennai. The second session was on blockchain for secure industrial transactions and supply chains by Mrs. Jiva Kadirwani, Supply Chain Manager, Chalantis, Dubai, UAE. Both the sessions enhance the competency of faculty in equipping students with industry-relevant VLSI design skills and project ideas in intelligent manufacturing, smart supply chains. Day two, the two sessions were on the topics 5G and next-gen wireless communication for industrial applications by Dr. M. Ghulam Nabi Alsad, Deputy Director, Center for Research, Associate Professor, Department of ECE, Anna University, Chennai, and Edge and Folk Computing for Real-Time Industrial Applications by Dr. S. Benila, Assistant Professor, Senior Grade, School of Computer Science and Engineering, Vellore Institute of Technology, Chennai. The program focused on the role of antennas in next generation communication and how to design and implement industrial solutions using edge and fog architectures. On day three, the program was on additive manufacturing in Industry 4.0 by Dr. S. Karthikeyan, Associate Professor, Department of ECE, National Institute of Technology, Trichy, and Smart Sensors and Embedded Systems for Real-Time Monitoring by Dr. S. Madhava Pandian, Director, Embedded Systems, Taras Systems and Solutions, Bengaluru. The session focused on the integration of smart sensing technologies, embedded systems, and additive manufacturing to develop innovative and real time solutions. Day 4, the two sessions were on the topics Advanced Hardware Technologies and Security in Embedded Systems by Mrs. N. Shubhashini, Engineering Specialist, Curtis Wright Corporation, Ottawa, Canada, and Engineering for the Real World, Ethical, Domain Aware AI and IoT Solutions for Industry 4.0 by Mr. T. Sivapunniyam, founder and CEO, Signatech, Milwaukee, USA. The sessions focused on the convergence of hardware innovations and IoT based solutions that are driving Industry 4.0 and next generation smart systems. On day 5, the program was on artificial intelligence and machine learning in industrial automation by Dr. V. Masilamani, Professor, Department of CSE, Dean Student Affairs, Indian Institute of Information Technology, Design and Manufacturing, Kanjipuram, and Proposal Funding Schemes in India and Writing Meaningful Proposals by Dr. T. Ramprabhu, Scientist E and Joint Director, DRDO, Bengaluru. And today we ended the program with sessions on robotics and autonomous system in smart industries by Dr. K. Sujata, Professor, Department of EEE, Dean Consultancy, Dr. MGR Educational and Research Institute, Chennai, and Digital Twin Technology, Sustainable and Green Manufacturing Technology by Mr. N. Rajbharat, Project Manager, Saint Gobain India Private Limited, Chennai. The sessions highlighted how robotics, digital twins, and green technologies are revolutionizing modern industries by enhancing automation, efficiency, sustainability, and innovation. Overall, the FTP served as a platform for capacity building, knowledge enhancement, and skill development, empowering faculty members to train students effectively and contribute to academic excellence. Thank you.
Thank you, ma'am. As we strive for continuous improvement, we request you all to kindly spare a few minutes to share your valuable feedback on the sessions, resource persons, and overall organization of our FDP program. So, participants, kindly unmute yourself and you can share your feedback.
I have unmuted you so you can share. I think.
I request the participants to come forward and share your valuable feedbacks.
Good evening, everyone. I'm Shivani from Odisha. I had joined in this ATAL FDP program on smart systems and emerging technologies in Industry 4.0. I would like to mention first that this is my very first FDP, and I'm very new to this journey. I just have 6 years of teaching experience until now, and I truly feel very, very privileged to have been a part of such a learned gathering of distinguished faculty members and research scholars and researchers and academicians. For me, it has been very, very humbling and as well as a very inspiring experience. What I particularly valued was how much I got to know the real industrial use cases and advanced applications. As ma'am told that now Industry 4.0 is not just a buzzword. We are transitioning into that, and the real background use cases in industries has been very, very informative. Whether it was on edge AI, whether it was on smart sensors, fog and cloud computing, digital twin today, and a very, very informative session on research proposal writing and various funding schemes by Dr. T Ram Prabhu sir, which was yesterday evening, and which I was completely unaware of. I was wowed by the level of developments that we have, and I was really not aware. So the depth of the content and the clarity of delivery by all the resource persons and the experts were absolutely profound and very much eye-opening. So on behalf of all the participants and I myself, I would sincerely thank AICT, the organizers and our coordinators, and the eminent resource persons from academia and industry for their efforts in curating such a detailed and comprehensive enriching FTP for us. And as Dr. Durga Devi ma'am just now said, that this is just a beginning, and it will surely be a catalyst in moving forwards towards this, transformative journey for all of us. Thank you so much, everyone. Thank you.
Thank you, ma'am. Anybody else?
Hello.
Yes, ma'am.
Yeah, myself Ashna Unnikrishnan from Bharat Institute of Higher Education and Research. First of all, I would like to sincerely thank the organizers and the resource persons for conducting such a well-planned and insightful program. The sections were extremely informative. It also covered a wide range of topics, including IoT, edge computing, then digital twins, and smart manufacturing technologies also. Actually, it gave us a clear picture of how Industry 4.0 is transforming different sectors with some real-time application and the case studies. And thank you. Thank you for conducting such a wonderful FTP.
Thank you, ma'am. Anybody else?
Yes, madam.
Yes,
Sir?
yes, yes, sir.
Yeah, you can
Yes.
continue, sir.
Yes, I am K.R. Ganesh, Assistant Professor in EC Department of SRM Valliyam Engineering College. Good evening to all those who joined in this ATAL FDP on smart systems and emerging technologies in Industry 4.0. I take this opportunity to share my views on this FDP. I am happy to share that I have learned various concepts related to emerging technologies like IoT and smart systems. And to mention a few, the importance of VLSI design, communication systems, cloud, edge, and fog computing, smart sensors, digital twin, in designing system in Industry 4.0. This FDP helped to know insights about the role played by AI and ML in developing smart systems. The resource persons and subject experts are well balanced and mixed comprises of industry and academic field. All the speakers were informative, especially the session handled by Mr. D. Sivapunyam, founder and CEO of Signat Technology USA. He made evident, he revealed that there is a gap between academic curriculum and latest industrial technologies. He also mentioned the skill sets needed for the aspirants in this field. So as a whole, the FDP was very informative and well organized and well coordinated. I thank all the guest speakers and organizers and college for this online ATAL FDP. Thank you all.
Thank you so much, sir. Anyone else?
I'm Heyalata Balakrishnan from MAM College of Engineering and Technology, Tiruchirappalli. All the sessions are more informative, and then it includes the Edge AI, then AI, ML, latest technologies towards the Industry 4.0. They are going to run it in the future. You have covered well all the speakers. They have covered very well, and then they have given the insights related to the Industry 4.0. Thank you for the organizer for arrange this FDP. Thank you, ma'am.
Thank you, ma'am. Anybody else?
Yes, ma'am. This is Uma Maheshwari from Savita Engineering College.
Yes, ma'am.
Yes, I first of all, I congratulate the FDP coordinators and the conveners of ATAL FDP, organized by Prince Bhavani Engineering College. It was actually a well-planned and effectively executed program. So actually the talks covered the topics like robotics, autonomous systems, green manufacturing, and digital technology. So it has given a clear vision on how Industry 4.0 solutions can be adopted in real-world industries. And the resource persons actually shared both academic and practical perspectives. So the overall sessions provided excellent exposure to latest innovations. And also I felt like the active involvement of the coordinators ensured the smooth conduction of engaging the FDP. Thank you. Best wishes to you all.
Thank you, ma'am. Anybody else? Any other participant wish to share your feedback?
Ma'am, it's me.
Yes, ma'am. Please introduce
Ma'am,
yourself.
it's me, Dr. V. Kalaiselvi from Vellalar College for Women, E Road.
Yes, ma'am.
I wish to express the hearty congratulations for the institution for receiving this ATAL fund for organizing this FTP. And as all the participants informed you, we had a very informative session, and it is need for an hour. IoT and this 4.0 is essential for us at this time. So I appreciate the conveners for selecting the app topic for this hour. And also, I wish to express my sincere thanks to all the organizer. The information shared to us was very good, and the timing and session was well handled. And we are much satisfied with the FDP, which is organized for the past 5 days. We wish you all the very best for the future endeavors. Thank you once again.
Thank you so much, ma'am. Any other feedback from the participant side?
Hello, ma'am. I'm Anantalakshmi
Yes, ma'am.
from New Prince Sri Bhavani College of Engineering. I'm very much happy to attend the sessions of all 5 days. Each and every topic gave me more knowledge and it is very much understandable, ma'am. I would like to thank each and every conveners of our college members, and the program was very well organized and it is very much informative for me. I thank you each and every one of you all. Thank you so much.
Thank you,
Thank you, ma'am.
Uh, any
Yes.
other? Yes, ma'am.
Yes, ma'am. Yes, ma'am. Please.
Yeah. Any other participants wish to share your comments? Okay. Okay. So I thank all the participants who have shared your valuable inputs to us, and I hope it will definitely help us to enhance the quality of our future programs. Thank you so much. And now I would like to invite our program coordinator, Dr. V. Mangayar Karasi, Associate Professor of EC Department, to deliver the vote of thanks.
Yes, ma'am. Thank you, ma'am. Good evening to all. I take this opportunity to extend my heartfelt gratitude to AACT Atal Academy for their support and encouragement in conducting this program. My sincere thanks to all the distinguished speakers and experts who spared their valuable time to share their knowledge in next-gen wireless communication, smart sensors and embedded system, security in embedded system, AML, and digital twin technology in smart manufacturing. I express my sincere gratitude to our chairman, Mr. K. Loganathan, vice chairman, Mr. L. Navin Prasad, director, Professor A. Swaminathan, principal, Dr. T. Saravanan, for their continuous support and encouragement to carry out such initiatives. My heartfelt thanks to our beloved head of the department, Dr. G. Durga Devi, and faculty members of EC department for the dedication to ensure the smooth and successful conduct of this FDP. This FDP has not only broadened to our understanding of smart systems, but has also given us the tools and confidence to integrate these cutting edge technologies into our teaching, research, and professional practices. Most importantly, I extend my gratitude to all the participants who actively engaged throughout these sessions. Your enthusiasm and commitment have truly made this program meaningful and impactful. As we conclude, let us carry forward the knowledge we have gained and work towards applying it in real world context, whether in classrooms, laboratories, and industries. May this FTP serve as a stepping stone for many more collaborative initiatives in the future. Once again, I thank everyone for being a part of this academic endeavor. Wishing you all the continued success in your professional journey. Thank you.
Thank you, ma'am. Now I request all the participants to turn on your video for a photo. Jasmine, ma'am.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Done.
Okay, ma'am.
Actually, the assessment will start at 7:10. It will be for 1 hour duration, 50 MCQs. So try to attend at the prescribed timing. That is at 7:10 itself. Uh, Then after that, you have to fill the feedback form. Today, the feedback form you have to fill from the ATAL portal. Uh, Only once you complete the test and after submitting the feedback form only, you'll be able to download your certificates. So kindly attend the test at 7:10. It starts at 7:10. Attend the test and then submit your feedback form in the ATAL portal. Today, no need to fill, no, we are not posting any feedback form in the WhatsApp chat. So you fill the feedback form in the ATAL portal. And as you know, the procedure or the eligibility for getting the certificate is that you have to get a minimum of 75 marks, suppose, in the test, and 80% attendance is required. So adhere to that and try to attend the test at the prescribed timing. Thank you all. Thank you for your cooperation.
I once again thank all of you for your active participation throughout the program and making this FDP program a grand success. I thank all the participants who have shared your valuable feedbacks. Thank you all.
You log in into your ATAL portal. There you can see the tab as test. In that
Assessment, ma'am, not a test.
assessment. There you'll have the questions. You just attend that, and after that you fill your feedback form to get your certificates. Thank you. Anything, any hurdles if you face, you just text in the WhatsApp. We'll support you. Thank you.
Okay. So Jasmine ma'am, shall we leave?
Yes, ma'am. Yes, ma'am.
Okay.
Thank you. Thank you all.
கூட வந்துட்டு டேய் பையன் ஆமா 50th மேரேஜ் இப்போ ஸ்டாலின் கூட வாய்ப்பு வச்சு கொண்டாடிடுறாங்க சீஃப் மினிஸ்டர். அது மாதிரி கொஞ்சம் பேருக்கு தான் அந்த வாய்ப்பு கிடைக்குது. 50 வருஷம் வாழ்க்கை திருமண வாழ்க்கைலாம். அதனால அந்த ஒரு சிறப்பான விஷயம் தான். அம்மா உடம்பு முடியலன்றதால நிறைய பேர் கூப்பிட முடியல. அதனால கூட நீ கொஞ்சம் இருந்துட்டு நீ உனக்கு வேலை இருக்காது. நீ மாட்ட வீட்டு வேலையும் பார்க்கலாம், மற்ற விஷயத்தை பார்த்துக்கலாம். வரவும் போறவங்க கூட நீ கொஞ்சம் இருந்தா சந்தோஷம். வரவும் போறவங்க ரொம்ப சந்தோஷம் சார், வந்து வாழ்த்துன்னு சந்தோஷம் சார் சொல்லி கொடுத்து அனுப்பிச்சுட்டு ஏதாவது வரவும் போக சாப்பிடுங்க சார் அப்படி ஏதாவது ரெண்டு பண்ண எதுவுமே நீ ஆர்டர் பண்ண எதுவுமே காஃபி டீ கூட ஏதாவது வாங்கி வச்சுக்கோ. ஒரு 2 பில்டர் வாங்கி வச்சுன்னா போதும். ஒரு 10 பேர் காஃபி வாங்கி வச்சு கூட போதும். வரவங்க சும்மா ஒரு காஃபி கொடுத்துட்டு 2 நிமிஷம் பேசி கிளம்பிடுவோம். ஏன்னா உடம்புக்கு ரொம்ப காசு மாட்டாங்க. போறவங்களுக்கு ஏதோ அப்பா சொன்னாரு மிக்சர் ஏதோ வாங்கி சொன்னாரு பாக்கெட்ல அவர் அது மாதிரி ஏதோ